right, well, questions 2 and 3 were about integration by parts, trying to separate the scale of figuring out what to define as our u and our dv, and as well as just knowing what that general formula is. So the formula for integration by parts, the integral of u dv, the things that we identify each time we start integration by parts formulas, is equal to uv minus the integral of v du. All right, as I said in class, really important that you have that left side of that equation as well as what we actually use every time, that uv minus v du. All right, and then we have lots of ways. And number 3, I typically will give you questions that will fall nicely into the LEAT or LIPIT sort of acronyms that will help you. I guess they're not acronyms, they're initialisms, that will help you sort of figure out what to use for your u and your dv. So if we just have ln, this is the question we just saw in number 1, we want to set that as our u, because the magic thing is when you take the derivative of a logarithmic function, you end up with an algebraic function out, which is really lovely. And then strangely, we might be like, oh, I don't have a dv, but we can just set the dx there as our dv, which means that our antiderivative is just x. And you can already see if I multiply the v and the du, just like what happened in the previous question, my x and my 1 over x are gonna, that's just x over x, which is 1. All right, then we have the lovely one that you have to like circle back like a snake eating its own tail to solve. This one, honestly, either one is going to be perfectly fine. I like to set in these questions whichever, if there's only one, whichever function has a constant multiple of the actual argument as my u, because I like when I take my du to end up with nice, beautiful whole numbers, because that we're using the chain rule instead of doing u sub. It's just a slightly easier process that's going to result in not having fractions running about. But both questions would have, both choices would have been correct here. So in this case, that makes my dv cosine of x dx, and then my v would have been sine of x. We get a bonus in this one. Not only do we keep nice whole numbers, no fractions, but no negative signs to have to keep track of as we move forward. Okay, the next one, we have something that we'd have to probably do, we'd have to do multiple integration by parts or use the tabular method. Either way, we know that we're going to start with that polynomial or algebraic function as our u. So my du is 3x squared dx, and my dv is going to be the exponential, because unfortunately for us, or not fortunately, but exponentials don't get any worse as you take antiderivatives of them. And so in this case, our v will be a 1/5 e to the 5x. So we don't get to leverage what we did over here by making that exponential our u. We do end up with a fraction. It's okay. All right, and then the very last one, yes, I could distribute the sine of x over 2 to both of the terms in that nice little linear function, but as we've talked about in class, that tends to mean that you now just have 2 antiderivatives or 2 integrals to handle, and I see more mistakes working with those 2 integrals in terms of the communication or remembering to take antiderivatives. And no matter what, we still have to do an integration by parts. So it makes sense to just go ahead and do the integration by parts with that linear function instead of distributing this. So if that's the case, again, we have a nice algebraic function. Our u is going to be 3x plus 2. Our du is equal to 3 dx. And our dv is equal to sine of x over 2, which does mean I have to pay attention to a bit u sub in my head, but thankfully since our constant multiple here, that scalar that's happening to our x is a 1 over 2, when I divide by that, I will get 2 cosine of x over 2, and it will need to be negative. All right, so that was the answer to 2 and 3. Typically, I think this one has not been bad for students. There is some struggle typically when I throw in either one of the inverse trig or ln sometimes, because they don't see the 2 different functions. Students will struggle with those and end up leaving them blank. But remember, both of the initialisms, LEAT and LIPIT, those both have L as the very first for logarithms and I as the second for inverse trig, because both of those things, as you take derivatives, turn into something algebraic, which hopefully then we can either have lovely canceling happening, what happens with my ln, or potentially a u sub or something nice is a nice way to get out of it, like we might see with our inverse trig functions. So that's 2 and 3.